So the main goal of Tor is it allows users to anonymously connect to a website or like browse the internet. So normally, like for example, we're gonna draw a little computer. That's a computer, and here's you. Okay, your little Jimmy. Well, that's horrible. Anyways, so yeah, you want to connect to some web server, and this can be just like any website like facebook.com or something. So normally your internet service provider allows you to connect like using a router. It'll like forward your packets of information to the web server will send it back, and this is great. But here's the thing, your internet service provider, and these providers are, like Verizon, Xfinity, AT&T, I think. They know who you are, they know like your IP, and they know the web server's IP address. So even though like you could be using HTTPS, which encrypts your traffic, so maybe your internet service provider doesn't necessarily know what you're sending to this web server, they still have a log saying, okay, this person is connected to this web server. Okay, well, some people might be like, well, it's not a problem. I'll use a VPN. VPNs essentially allow you to like have like the web server. It looks like it's communicating to a different IP address than your own. But the thing with a VPN is, it's great for making it look like you're in a different geolocation. The great thing about a VPN is it helps like hide your geolocation from the web server. So if you want to, access the Disney Plus and look like you're accessing it, oh my gosh, from a different country, a VPN can be useful. Also, if you want the web server to not know like what IP address you're like connecting from. But here's the thing, now you're just shifting your trust from the internet service provider to your VPN provider. So your VPN provider still knows who you are and what services you're connecting to. So, what if you don't trust either your internet service provider or your VPN provider? Okay, this is when you're going to want to use Tor. And Tor essentially has a bunch of relays to forward your traffic to the server. So let's talk about how this circuit, this kind of like called a circuit, is set up. So essentially, you're going to choose 3 relays, and these relays are publicly known. They're publicly known specifically like Tor relays. And you can choose more than 3, but 3 is a pretty good number because it allows you to be anonymous enough. But if you have more than this, then it's going to slow you down a little bit. So we're going to have an entry relay. We're going to have a middle relay, and then we're also going to have an exit relay. Okay, all publicly known. And then what we need to do is we need to establish and share keys between all three relays. So I'm going to have key 1, key 2, key 3. Okay, so now what I'm going to do is I'm going to first, using like TLS or like Diffie-Hellman key exchange to share this key, I'm going to share key 1 with the first relay. Okay, that's great. And now I want to share another key. Okay, key 2. Key 2, okay. And then, yeah, so but essentially I sent this with the TLS, or like Diffie-Hellman key exchange, to give the first node this shared key with me. Then I'm going to use the entry relay. I'm going to do this key exchange again for the middle one through the first one. So I'm using this as a proxy, okay? So now it has this one. I'm going to use these 2 as well to exchange and establish a third key with the last node. every relay only knows its own key, and it only knows the previous and the next IP addresses. So this exit relay isn't going to know your IP address. It only knows the middle and the final one that you want to send traffic to. Now that I have this circuit created, what I want to do is I want to actually send traffic over Tor. So I want to send some sort of message. Maybe my message is as simple as connect to this website. Then what I'm going to do is I'm first going to encrypt this message with the third key. And then I'm going to encrypt it with the second key. And then I'm going to encrypt it with the first one. So notice how this is creating a bunch of layers. And that's actually how it Tor is known as it uses onion routing. This is my poorly drawn onion because it's creating layers. Okay, so this message is being forwarded to this first relay. The relay is going to take this. It knows the key for the outside layer, so it can actually remove this encryption, and it'll tell, once they've decrypted it, it will say, okay, now send this to the second relay. So I'm going to send this message again, but now I have basically, oops, I'm doing this in the wrong order. Yeah, so the pink is still on the inside. So yeah, now it looks like this. Now I only have 2 layers. Okay, now the great thing is the middle relay has this key. It can remove this yellow layer. And now we have the message. And it only has it's only encrypted by the last layer, pink layer. And then this relay will remove this. So now we're just sending whatever we want sent to this web server. This can be facebook.com, it can be whatever website you're trying to visit. So something that's important to note is that these web servers, because these relays are oh my gosh, they're publicly known Tor relays, and I'll highlight them to be purple. This website could be hey, okay, well, this server, this relay is from Tor. I don't want to have any Tor connections. So certain websites can block Tor connections just in general. And, as a user, there's really nothing you can do about it. You simply will not be able to connect to this website with Tor. The other important thing to note is for this connection, your internet service provider is allowing this initial connection. And they could actually block this. They could say, hey, we recognize what you're trying to connect to is a publicly known Tor relay, so we're not going to allow this. And this is more common in certain countries that are trying to censor your trying to censor your internet access. For example, maybe you're in an authoritative government, such as China and Russia, and they'll block this connection. But there is actually kind of a sneaky solution. They'll add an extra relay called a bridge. Okay, and so now you're connecting through this to your entry relay. And basically, these are publicly known, but the bridges are they really shouldn't be publicly known servers, so it looks like a normal connection, not a Tor connection. It's not foolproof, but it's a pretty good way to allow people from these countries to still connect to the Tor network and browse anonymously and browse maybe websites that their government might try to block otherwise. So really, how secure is this? Well, TLS still needs to be used. So really, when we're connecting to this web server, we really want to have HTTPS, not just regular HTTP, because we still need this message to be encrypted. What if we have someone sniffing this from the exit to the web server, sniffing this traffic? Well, we don't want them to be able to read our message in plain text. Also, another important thing to note is what if you had previously logged in, not using Tor, to this web server, and you gave maybe it's facebook.com, and you put in your username and password. Well, they've already stored, okay, this IP address is connected to this login information, and if you connect through Tor, they could do some pattern recognition and be like, hey, you previously logged in with this IP address, and that can be used to de-anonymize you. Another way that you can be de-anonymized, and honestly, this is this is quite difficult to do, so it's not super common, but it's known as a correlation attack. So an attacker who has access for this traffic, they can sniff this traffic, and they can sniff this traffic. This part is important because they know who you are, and this part is important because they know who you're visiting. Well, for example, what if you're visiting this website and sending a lot of traffic at 2 p.m. and then a lot of traffic at 8 p.m. And then because the onion routing is fairly low latency, so you should still be able to browse fairly quickly, this pattern will look fairly similar. And they might be able to correlate, okay, at 2 p.m. we also saw this web server visited, and there'll be a bunch of other traffic. So they don't necessarily know this is yours, but they can see with a lot of traffic, high volume of traffic, they can start to correlate these patterns and connect you with the web server. This is really difficult to do. Another reason this is difficult to do is because your exit node will likely be changing a lot as well. But yeah, it's another possibility. The last thing I wanted to know is something called a hidden service. And essentially, instead of the web server being outside of Tor, it's within the Tor network as well. And the really important thing about this is now the server's IP address is not revealable, so you won't be able to access, or anyone won't be able to know the specific web server's IP address. And it's quite complicated how that works, but one of the main reasons that's used for is to hide certain services. Maybe there's certain websites that are doing illegal activities like selling drugs or selling malware. Well, they can be sort of hidden by being considered a hidden service and being a Tor server. And it's also important to note that these hidden services can only be accessed through the Tor network. There's no other way to connect to them. And they're also given, they're identified by a .onion address. So that's just a quick overview of Tor. Yeah, just know it's not always used for bad things. Really, it's just to allow you to browse the internet anonymously and have your privacy be protected. So, it really is a good thing. But yeah, sometimes it can be used for illegal things, activities, but also, it's really helping people in countries that are restricted to still browse the internet and get their information, or it allows, journalists to report information to countries that might have certain websites blocked, and it also, allows whistleblowers to, truly be anonymous. So there's still a lot of great things about Tor. So that's it in a nutshell.